Hello and welcome to this quick video. What I'm gonna do is start from basics of algebra and then get finally to how to solve second-degree equations. So completing the square, the quadratic formula, all of it will be in this video. So first of all, we need to start from somewhere, and that somewhere is remarkable identities. What are remarkable identities? Well, it's something that you remark with your eyes, and they are identities, which means they are true every time. It's like your identity card. It's specific to you, and it tells your truth in some sense. So you have a times b, the whole thing squared. We know this gives a squared times b squared. Any two numbers multiplied, the whole thing to the power gives the power splitting. A divided by b, the whole thing squared, gives you a squared divided by b squared. We know that as well. Okay. What we don't know is what this is and what this is. And I say we don't know because they are definitely not. This is definitely not, I wanted to pick red, definitely not a squared plus b squared. Definitely not a squared plus b squared minus b squared here. Never do that again. It's a very common mistake. Don't do it. Okay? So the question becomes, what is a plus b the whole thing squared? And a plus b the whole thing squared is just what anything squared is. It's the thing multiplied by itself. That's how I know what it is. And so a times a is a squared, a times b plus ab, b times a plus ba, b times b is plus b squared. Fantastic. And now this is just a squared. ab and ba are exactly the same thing. 2 times 3 and 3 times 2 are the same. So this becomes 2ab and this becomes b squared. And the first magic formula is born. This is what it is. Every time. And how does it work? Well, if you have 2 plus 3, the whole thing squared, well, this just gives 5 squared, which is 25. But using this identity, and I'm going to do the dumb thing of doing this here. So this gives 2 squared plus 2 times the first number, which is 2, times the second number, which is 3, plus 3 squared, which is 9. Okay, now this looks very weird when you do it like that. This also gives 25. This looks very weird when we do it like that because this is the shortest route. Of course, do this, of course. But the problem is, when you don't have a plus b, sorry, when you don't have known numbers, when you have a plus b like that, how would you know? There's no way for you to tell what a plus b is. I have no idea what a plus b is. So I cannot move forward like I did here in this case. Okay? So this is what a remarkable identity is. It's a nice result that is the same every single time. Okay, and same thing for what is a minus b squared. It's not, again, a squared minus b squared. Don't do that. Okay, this is a minus b multiplied by a minus b. And what is that? A times a squared. A times minus b, minus ab. Minus ba, minus times minus plus b squared equals a squared minus ab, and ba are the same thing, 2ab plus b squared. And the second remarkable identity is born. Okay. Now, the third one is a bonus. The third one is, what's a minus b into a plus b? That's the third one. And this gives a times a squared, a times b, ab, b times a minus ba, minus here, b squared. Why did I think of this? So this is number 1, this is number 2, and this is number 3. Why did I think of doing plus minus here? Well, because if you notice here, we had minus and minus. And here, if you notice, we had plus and plus. So the natural thing to do is to mix them up. And it doesn't matter which one you put minus, which one you put plus, of course, because it's the same thing. You're just reading it in reverse. And so here, if you notice, plus ab minus ab cancels out, and you're left with a squared minus b squared. And this is the third remarkable identity. There you go. And this concludes part 1. Follow us, join our Discord, and join us live on Twitch if you feel like it. See you next time in the next video if you want to see how we use these remarkable identities to continue until we reach solving second-degree equations. Take care.